Hey, g'day, it's Prezzo here and welcome back to part 2 of the drawbar hammer build. In this video I'm going to have a look at the timber handle I want to make for this tool. I've done a 3D model of what I want to achieve here, and it's just your basic tool handle. This was done in Autodesk Fusion, and I used a lofted profile to get this three-dimensional shape. The construction I want to use is going to be from wood, and it's going to be laminated in sections. If you've ever seen an east wing claw hammer with a leather laminated handle, you'll get the idea of what I want to do. It's going to be made from square sections of timber, and there's some here I've already started preparing. These are roughly 45mm square. The biggest diameter of the handle is 40mm. So this stock is going to be drilled about 10.5mm in the center, and it will be stacked on this piece of 10mm metric thread rod. And when I have enough of these pieces to clamp up the full length of the handle, it'll be glued together with epoxy resin glue, clamped with a hex nut, and then I'm going to try CNC machining this in my CNC mill. Now, I don't have a CNC router, but I've tried this out and it does work if you use a woodworking router bit, and if you use it at maximum speed and keep your feed rate low, it does actually work. And given that this stuff is going to be pretty much impregnated with epoxy resin, it's going to stop the grain from tearing up. So what I've got is a whole bunch of different types of timber. That's some Tasmanian oak, that's some flame she oak, that's Huon pine. I've got some, what is that? That's New Guinea rosewood. So the next step in this process is to get the rest of this stock cut up. I'm going to be using my table saw and a tool that I found on a YouTube channel called Mirox Woodshop. And I'll put a card in this video so you can go and check it out for yourself. It's a fantastic tool. It was designed specifically, or in my case it was built specifically for doing this job. So let's go and check it out. So this is the device that Mirox on his YouTube channel called a vacuum pusher, and the notion is that you've got a sealed box, or in my case an aluminium tube. I think he made his out of plywood, and inside there is a piston which is operated by a lead screw. So you can adjust the position of the piston to uncover as many holes as you want, or seal off as many holes as you want. So in this case the piston is just here, and you can operate the lead screw with a spanner or a wrench, whatever you like, and you can move the piston inside that tube. So I brought that piston back to there, and you just match the number of holes that you need to the length of your stock. And on this end there is a fence, in this case made of PVC, so if I was to hit that with the blade of the saw, it's not going to cause any damage to the saw teeth. And that fence is replaceable, so if you need to remove it, there's just 4 screws and you can take that whole end off there. This end block is just made of high density polyethylene, and the handle also forms the connection for your vacuum. So in my case I'm just using a shop vac to create the vacuum. So in operation you sit your stock against the fence, turn your vacuum on, and then you can cut as many strips as you want just by repositioning the stock each time. So let's give it a blast, see what happens. there you go, shop vac operated vacuum pusher. All thanks to Miroc. Good on you, mate. Good idea. Okay, let's get these strips docked to length now and drill them, and we can start assembling the stack of material for the handle. So I'm pretty sure you've worked out by now that what I need to be able to do is to assemble all of these individual squares onto this threaded rod, glue it and clamp it. So each of these little squares needs to be drilled through, and I'm drilling at 10.5, so it's a slightly loose fit. Just makes it easier when it's got wet epoxy all over it. So I've got a simple little jig here, and I can do these individually or stack them. The thinner ones I stack 3 or 4 at a time. So let's go ahead and drill these. Okay, that should be enough. Okay, so here's the deal. I've got my piece of 10mm threaded rod. I've got all my material, timber stock ready to go on. And at this end, eventually there'll be this aluminium ferrule which will be fitted just underneath the hammer head. So eventually it's going to be threaded in like that. And I don't want to damage this when I start machining the wooden handle. So I've substituted that part with a piece of Delrin, and I've drilled that out so it's a fairly loose fit, and I've wound some masking tape around the thread at this end because I want to be able to get that piece of Delrin off later on when I'm finished. So if any epoxy seeps up into that gap, I should still be able to remove the Delrin, I hope. So the glue that I'm using is a West system. Anybody who's done any boat building will be familiar with this stuff. I bought this to do another job. I was making up some epoxy granite to fill the column and the base of my CNC mill. I also did the base and the column of my drill press, and it worked great. And it's got these pumps on the top of the container, so it's very easy to mix out or measure out the correct ratio, which is 5:1. So we'll go ahead and get some resin mixed up. Alright, I can always mix some more if I need it. So I'm guessing you could use any sort of epoxy, just like araldite or something with a fairly good strength though. I wouldn't use 5-minute araldite for this job. Okay, I think I'm going to sacrifice a paintbrush to do this. So the first piece of stock I put on, I want it to be a fairly thick one, so that as I clamp it up it's sort of not going to bend or compress or do anything like that. So it's now just a case of stacking my pieces, trying to get a bit of variety in the colour. So these Huon pine pieces are going to go on sort of at regular intervals, and then I'll mix up the thicknesses as well. Okay, let's just do this, maybe put a bit of music on, because it's going to get long and tedious and boring. Okay, see this is going to get messy, so just give me a minute, I'm going to go and get some gloves. Alrighty. Why does that always make people feel uncomfortable? Not sure. Okay. Alright, I need a finish length of 230mm, and I'm about 235, but I think this is going to compress up a fair bit. So I'm going to get a nut and a washer on that. Okay, that's good. That's exactly 230. So I'm just going to let that set, and then I think I'm going to put this in the lathe and turn it perfectly cylindrical, and then onto the milling machine we'll do all the tricky CNC stuff. So let's check in tomorrow and see how this has gone. I got to clean everything up now. Everything's covered in glue. Well, here we are the next day. I've let this epoxy set overnight and came off the paper quite easily, and it feels really solid and rigid, which is what I was hoping to get. Because I've only got a little brain, I sort of forgot that I should have put a center drill hole in the end of this threaded rod before I started assembling all these parts. And what I need to do now is support the end of this stock on my tailstock center while I machine this down to a cylindrical shape. So I just made up this little nut, I guess you'd call it, and it already has a center drill hole in the end. So this is just so I can support it between centers, and I'll need to do this later when I machine this on the CNC mill. So this will sort of stay there permanently, and I'm going to grip this in the headstock just by that Delrin spacer that I made up, and other end on the tailstock center. And I'm just using a high-speed steel tool here just to remove most of the material off this, because on the mill I'm using not an optimal setup really to do this, so I don't want to be taking off a lot of wood. So let's go ahead and get this machine down now. Okay, that's not too bad. I'll give it a couple more passes. Alright, I think I'm going to leave that there because remember, this is not the finished pass that I'm doing. This will be done on the mill. So we're going to transfer over to the mill now. Interestingly, as that's turning, you get a whiff of each different wood as the tool starts to abrade the grain, and the Huon pine smells beautiful. It's got a really unique sort of odour to it. So although that finished a bit rough, I'm not bothered with that. So let's go over to the mill and get busy with the interesting part of this whole build. Well, we have arrived at the point that's been filling me with anxiety really. I'm trying to do all of this setup on a machine that's really not suitable. This is a Sieg MX3 CNC mill, or it started off as a Sieg X3 and it's been converted to CNC. I have a 12mm wood router bit which I'm going to use to try and shape this with. I think my spindle tops out at about 2000 RPM. And these cutters like to run at about 18,000, so I'm sort of seriously under rotating that cutter. However, I've done this before on wood and it does work. It's not ideal, but it does work. I am also using Fusion 360 to generate the toolpath, and I normally don't use that. I normally use Kanban. So I'm a bit unfamiliar with the process, and I've been through several iterations of the NC code before I got one that I think works. So I've run this dry with the cutter, a good 50mm above the work, and it seems to be okay. And I've run it, done my offsets, and I've run the cutter to its first cutting point, which is just here, and it seems to be behaving itself. It seems to be doing what I expect. So the other unknowns are that I'm using MSM, or Max Standard Mill, as my machine controller. This is also new to me. I purchased this a while ago because I wasn't happy with the probing facilities in the old standard Mach 3. And with Max Standard Mill, it's got lots and lots of different options for probing. I also purchased a brand new probe. This one has a 2mm ruby tip, and I've been able to configure this so it does give me repeatable and accurate results. And I was intending to do a video on this some time ago, but just things overtook me. I didn't get around to doing it. So what I'm going to do now is to run the first tool path, and you can see that all I've done is I put a square collet block in the vise at this end. I've made a fairly quick and dodgy tailstock at this end, and nothing's super precise and accurate, but I think it's going to get me the basic shape that I want for this handle. When I've done the first tool path, I'll just flip the job over 180 degrees, do the other side, and then I've got a second tool path, or a second cutting operation, that will do the sides of the handle. Oh, that sort of worked a bit better than I thought it would. It's quite a rough surface that I've got there, because I'm using 3mm step over, and there was a little bit of chatter as we were cutting that, especially in the deeper section. So all I'm wanting to do is get a basic sort of form, and then I'm going to hand finish this. So I don't know, that's alright. So there's the basic form. And this is the thicker part of the handle just here, and so what we'll do now is just flip this over and just do the other side. Okay, so I've got the two sides done now, or top and bottom actually. So I'm going to have a go at doing this other profile now, which will actually be the sides of the handle. And I think this time I'm going to do a roughing pass. That last cut that I did, you can hear the chatter. It really was running that cutter too hard given the spindle speed that I have. So let's see if we can do better next time. Well, that was the third side, and I did a roughing pass, or at least a 4mm step down, so it took off the bulk of the stock and then did a sort of a 4mm finishing pass. And I just realised that what I didn't do was I drew the stock in Fusion 360 as a rectangular block, and in reality it's not. It's a cylinder, so that's part of the reason why I'm getting such a deep cut at the beginning. But that's alright, I'm happy with that. It's got a few ridges and lumps and so on, but they'll all come off in the finishing stage. Okay, well it's a bit gnarly looking. I think I probably messed up. Yep, I have messed up with my wire alignment, so I got a bit of a lumpy ridge here. That's alright. This end's good. I'm just going to have to do a bit of manual shaping down this end. But that's the first time this machine's ever done any truly 3D milling. And first time I've used Fusion 360 for a toolpath, and the first time I've used Max Standard Mill as my machine controller. So all in all, I'm pretty happy with that. I just wish I'd got this end correct. I probably rushed it a bit getting that set up. Anyway, we'll get this cleaned up with a rasp, then a file, and then we'll sand it smooth and see how it looks. Well, this is what happens when you get carried away making videos and don't spend enough time checking your setup. When I had this in the milling machine yesterday, I set my Y origin from the headstock end, and I didn't bother coming back and checking it at this end. It just looked right, and I just went with that. And what you can see is that it's offset the Y axis of the machining process toward this side for this edge, and as a result I've got all of this stock here now which is sort of skewed, and it's going to have to come off. So to get a symmetrical end on this handle, I've got to remove all of that stock, all of this stock here, but I think it's still going to form an acceptable handle when I'm done. So let's have a look at that process now, just for doing the shaping, and we're nearly done. Okay, well, I think this is as well finished as I'm going to get it. I finish up the 240 grit paper, and I'm just using a clear acrylic gloss. And although I don't like using spray cans to finish jobs like this, unfortunately there's just so many compromises required to put paint in a can. It's never as good as mixing your paint and using a spray gun. But for this job, it's going to do. So let's go ahead and give this a couple of coats. Alrighty, how good is that? So let that set and just rub it back. I'll probably do about 3 coats. That first coat's dry, so I'm just going to give this a rub back and do a second coat. Starting to get a bit of a gloss on it. Looks alright. Oh, there it is, all done. I've let that dry for about 2 days now and the finish has come up quite nicely. So, let's get this thing assembled. Alright, there it is. So let's go and check it out, see if it works. Okay, righty tighty and lefty loosey. And now you can use the copper face to knock out that drawbar. You know what? I reckon that copper face is going to be in pristine condition when I show you. Oh, what the f***?